Hi again, everyone. Welcome back. This is the second part on a video series, video over TCP/IP. I said originally that this was going to be a two-part series, but it looks like it may very well be a three-part or even a four-part. So thank you very much for those of you who have been watching the first video, the number of subscribers that have subscribed to the YouTube channel. I'm pleasantly surprised, which is really cool. I think that just speaks to how important or how much interest there is in this topic, which leads to a couple of slides I've got on here. So first of all, let's just bring up the slide that we had last week, just as a refresher. So I had to put up a slide last week, or last time, was NDI connections using TCP/IP. And we had a computer system, in this case vMix, but it could be, again, any kind of video system, switcher, etc., that's connected to an Ethernet switch. And then we are connecting all of our video sources via Ethernet. So what we have is we have some bird dog devices that are directly plugged into the switch that are going to an SDI camera, an HDMI camera, or to some NDI and some PTZ optics, and even there is some new Panasonic cameras, etc., that are coming out. So this is what we discussed last week, and we really talked about what is involved and the problems and solutions for how to make sure that your Ethernet side of things are working well. So this week we're going to be going into more on a discussion on the wireless side of things. But before we do, there were a couple of two questions that came up that I just wanted to address. So the first one is really, what is NDI? And it's a really good question. First of all, NDI is referred to as Network Device Interface. It is a open protocol developed by NewTek, so it's a trademark protocol, and it's really designed to enable video-compatible products to share video across a local area network. And it sounds like a big, long title, but it is something that's fairly unique, and it really has taken off. And so a lot of people said, well, why? Is it really cutting edge? Is it really something new? Well, in fact, it's not really. It's not the first, and it's not the only video protocol out there. We've been using a variety of different video compression techniques, video surveillance, streaming, all kinds of other things that have been out there for quite some time. And there's even some proprietary protocols that are used by larger video manufacturers. So NDI is not something really new. So what makes it really special, or what makes it unique? So what makes it really different? So first of all, it's dedicated to video compatible products. And there are, again, all of those other protocols, compression and video streaming, etc. All of those are out there. And there's those proprietary things, but really this is the first one that is dedicated just to video compatible products. So that's the first thing. The second thing is it's really designed for high resolution video over TCP/IP with ultra low latency. So some of the other protocols out there are, for example, the compression techniques, and even for video surveillance, the focus is really on trying to get those protocols across Ethernet in the small size, so they're really not too concerned about latency. They're not really that much concerned about video quality, etc. So this is really designed for high resolution video at that low latency, and that makes it really useful for television production. The next thing is it's highly efficient. It makes kind of a compromise between compression and that high quality. So there is, in fact, NDI does compress. It uses significantly less bandwidth than raw video. So something that's coming in over SDI or HDMI, that's considered raw video. So it does compress that. And if you were to send that raw video across, it uses about a 15th of what that bandwidth would be required to run. So there is definitely savings, and it's really trying to get below that 100 meg bandwidth limit. So the other thing is it's not limited to video. So it will also do audio. It will do tally lights. Its PTZ control, for example, can be done over it. There is also talk about the next gen, or maybe even later on this year, or 2018, where you're going to be able to see intercom to camera operators, etc., that are put over this. And also there's some other companies that have already added some interesting things. The original idea was to do video over a local area network, but there's actually a company that is doing it over a cloud in a worldwide situation. So you could take an NDI camera, for example, being in Australia, send it up to the cloud, and then be picking it up at a local studio level and be using it that way. So there's lots of additional features that are coming. It's bidirectional, so you can send video and audio, etc., in any direction. It's not simply a one-way. And it also has auto discovery, and this makes it really, really easy to use. Before, you would have to type in a lot of information, have a lot of setup in terms of hooking devices together. This is basically plug and play. You plug it in. As soon as the device is live, you'll see it as an NDI source. And again, it's bidirectional. So very easy to use. It's available for software applications, so it's an SDK that people can download and install it in basically any piece of software that they want, and it just has it as a plugin. And it also allows you to put it into hardware devices. And then finally, and this is probably the one reason it's really taken off, of course it's good, but it's also open protocol and royalty free. And this is what really has caught a lot of attention. NewTek developed this. It certainly is a good product, otherwise people wouldn't be using it, but there is no charge. So different vendors, different software vendors, hardware vendors can easily add it into their protocol suites and into their hardware and not have to pay royalties. So it is something that is really catching on quickly. As far as version goes, the very first version was put out in 2015, so not that long ago actually. It was good, but it had some real limitations. It was kind of first gen. And then version 2 came out about a year later. So this is the version that people started really getting excited about and really started to adopt. It had some significant performance improvements. It also started supporting all operating systems. So you could have Windows, Mac, Linux, etc. And it also started to have mobile support. So you started to see Android apps, iOS apps, different things running at the local level. This year is, in July, came version 3. And this is, again, a major step. So very first thing that was added was the ability to do multicast. Multicast allows one camera, for example, to that signal to be sent out to multiple endpoints, with only sending one signal. Before, if you wanted to send a camera, for example, to 3 different stations, it would send 3 individual 100 meg streams, whereas this allows you to send one signal and have multiple recipients. It also has something called HX mode, which is high efficiency mode, and this was again just introduced. And this allows really to run the system over wireless, which is what we're going to be talking about, and also for longer distances and international as well. It added PTZ camera control, PTZ camera control, and tally lights. And it also, and this was the other major thing that happened in version 3, is it had the ability to embed it into hardware. So that's where the camera companies are really getting behind this, and you're seeing a lot of development in that. So the requirements. So again, just as a reminder, NDI by itself, version 1, version 2, and version 3, not HX, but version 3, is the minimum requirements is 70 meg in the direction of the transmission. So from whatever way you're sending the data, you need to have at least 70 meg guaranteed. But it really uses anywhere between 70 and about 100 meg. So you really want to make sure that you've got, around 100 meg available. And it's usually about 1 to 1.5 frames of latency, so very, very low latency on here. Then HX has again just been released. This is a little slightly different. It has slightly higher, well, it has higher compression rates, and there are actually 3 different settings in this particular one. So you can have low quality, mid quality, and high quality. And even low quality is not low, but it is saves more bandwidth. You need to be about 10 to 15 meg of bandwidth that you need at the high setting. If you are going to use mid or low, it's obviously less than that, but the high requires about 15 megs. So that's significantly different than the full NDI. It has again a little bit more latency. Has about 30 milliseconds or another frame or so, frame to 2 frames over the regular NDI. And it has obviously a little bit higher compression rates, but it's still very, very usable, and especially for wireless applications. So the growth of NDI, there's lots of video applications out there already, NewTek, vMix, Livestream, Wirecast. Interestingly, one of the larger television company or production companies out there called Ross Video has just announced support for NDI as well. So I think you're going to see more and more different applications being used. Lots of software already. Here's some of the examples, but there's more. There's obviously titling, live text, NewBlue, Adobe Creative Cloud, ProPresenter, desktop capture, monitoring. So there's lots of software examples, and there's more every day coming. From a hardware, there is already NDI-enabled cameras, and this is just kind of starting, and that's partially because version 3 really added that NDI hardware, embedded hardware. But there's been a number of companies that have already been working it over the last year and a half. So there's NewTek has PTZ camera, PTZ optics, Panasonic, I believe Sony has made some announcements that they're going to be supporting NDI. And then there's a bunch of NDI converters already out there. BirdDog and the NewTek Spark is 2 examples of them. So there's lots of things happening, and it's just accelerating. So lots of really exciting things happening. So that is kind of the first question that has been addressed. What is NDI, and kind of I wanted to just give you a quick summary for those of you who are still a little foggy on what it's all about. The second question that came up was an interesting one, and I guess maybe because I just didn't cover it in any great amount of detail, there were a lot of questions on it, and that is related to PoE switches, how to get power over Ethernet. So when we take a look at power over Ethernet, I'll just bring up this slide here. There are a couple of things that you need to know, and again, I'm not going to go into great detail here, but there is the main things that you need to know is that there is 3 standards for PoE. There's something called 802.3AF. There's 802.3AT, which is newer, and then there's a brand new one that just came out this year called 802.3BT. You really don't need to worry about BT yet. Again, it's just come out, and for the most part, we don't have any real use for it yet. But then there's also something called PoE classes, and also you need to know about wattage. So these are the areas that we're just going to quickly go into. So first of all, what is 802.3AF? So this is the first PoE standard that came out. It's been out for a long time already. It basically was designed at 48 volts. So cameras, anything that you send out is all 48 volts DC. But the way this works is that when you plug in a device, let's say you plug in a camera into a PoE switch. So if you have an 802.3AF switch, what happens is when you plug in a device, the device and the PoE switch and your device basically talk. They send back a little bit of information, a little bit of power, and they try to negotiate what is called a class. And what that means is that the device tells the switch how much power it needs to send. So yes, it's 48 volts, but how many watts do you need to send? So if it's class 0, it sends full 15.4 watts, okay? Now, if you take a look on this, the device, the end device, the camera, for example, really only needs to be guaranteed up to 12, well, basically 13 watts. But the device, the switch, is going to be sending out 15.4, and that's because there's always some line loss. So if it's class 0, it's 15.4 watts. If it's class 1, it's 4 watts. If it's class 2, it's 7 watts. And it's class 3 is, again, 15.4. So, but basically, those are the different classes. Now, it negotiates. So if you have a device, for example, that is class 2, so for example, a bird dog device, again, I had a hard time finding this, but I ended up sending a note to bird dog, and I said, okay, are you 802.3 AF, AT, etc.? And they sent me back a note saying, yes, they are 802.3 AF compliant, and they are class 2. And the reason for that is that they operate under 7 watts. So what happens is when you plug in a bird dog, it talks to the switch. The switch says, okay, what kind of device are you? What kind of class are you? The bird dog sends back a message to the switch saying, I'm class 2, and therefore the switch starts sending 7 watts out to the bird dog. If you plug in something else, it might say, oh, okay, I'm class 3, or if it's an unknown, undefined, it sends out 0, which is 15.4. If you plug in a laptop, for example, obviously you don't want power to come out, so the switch is smart enough to say, hey, you're a laptop, you don't need power, and therefore I'm not going to send any power to you. So that is the older standard, the AF. There is a new standard called AT, and it's often referred to as PoE plus. Now, the only difference between the AT and the AF is that the AT can send up to 30 watts, and that's class 4. So again, the negotiation happens, but you really need to know what it is. So for example, let's say you take a Panasonic camera and you plug it in. Well, a Panasonic requires an 802.3 AT power supply because it draws somewhere around 20 to 22 watts, I believe. So if you plug in a Panasonic into an 802.3 AF switch, obviously it's not going to work because you don't have enough power. So you need to know, when you're buying switches, you need to know, first of all of your equipment. What is it? Is it AT? Is it AF? So if you buy an AT switch, it's backward compatible. So if you buy an AT, it will support all AF. If you buy an AF only, then obviously you're not going to be able to plug in any AT devices. So it's something that you got to keep in mind when you purchase switches. Now the BT that I just mentioned earlier on, don't really worry about it, but it basically goes up to 60 for something called class 3. And BT class 4 goes all the way up to 100 watts. So these are for more high-end power requirements devices, but that's something that you may see in the future. So just so you know that they're there. So just kind of to summary, let's say you buy a switch. Now I just went on Amazon. I'm not an advocate of Netgear or anything else. This is just a switch that I found. So this is a Netgear JGS 524 PE24. Okay, so you look at it and you go, oh, great, PoE switch. But it doesn't really tell you a whole lot of things about it. It just says it's a PoE switch. So when you start digging, and this is the problem with a lot of websites and Amazon, etc., it doesn't really give you the fine details of what it is. So I ended up going to the Netgear website, and I found out that this is in fact an 802.3 AF switch, not AT, AF. And that PoE is only sent to the first 12 ports. So although it's a 24-port switch, PoE is only on the first 12. Then the other fine print is that it only supports 100 watts. So what does that mean? Well, if you were to use class 0 or class 3 devices, you would in fact only to be able to power 6 devices, because if you go 15.4 watts times 6, you get 92.4 watts. So that's max. This switch will only put out 100 watts, and therefore if you plug in a 7th device, it won't power it because obviously it doesn't have enough power. Now if you have some class 1 and 2 devices, then obviously you're not using as much per port, and you would be able to use more than 6 ports. So then I looked at another switch. This is a PoE Plus switch. This is a Netgear GS724. This is a different switch. It's AT, and you can plug it in on any port, but the limit is 190 watts. So, well, what does that look like? If you were to have class 0 or class 3 devices, you would be able to use 12 ports, because 12 times 15.4 watts equals about 185 watts, which is the maximum of the switch. If you were to have class 4 devices only, you could only have 6 ports, because 30 watts times 6 equals 180. So again, if you had a mix and match, if you had some class 3, class 4 devices, etc., you could use more ports. But the point is that you have to be careful on how many ports you need. And the final switch here was found another one called a Netgear M4100. Again, I'm not an advocate for Netgear. I just found these on the internet. This is again an AT port, but it is rated at 380 watts. And on top of that, you can actually buy an external power supply, which will give you all the way up to 720 watts, which basically means that you can, if you had only class 0 or 3 devices, you could have all 24 ports active with PoE. And if you plugged in the 720 watt external power supply, you could actually power every single 24 ports with class 4 devices. So, so just so that you know, what you have to do is you have to really determine what kind of devices you have, how much power, what kind of class they are, and again, sometimes those are really hard to find, all of those little, itty-bitty pieces that are in there about what all of these things are. Okay? So that answers the first question, first 2 questions. So sorry for the long-winded answers, but now we are finally able to continue on with NDI over wireless. So what we're going to do is we're going to, again, bring up this slide. So the thing that changes here is the way this works. So yes, we have our box, we have our switch, we also might have some NDI cameras that are directly plugged in. We might also have some SDI and HDMI, of course, plugged in directly. But what we now have is we have some wireless devices. So in this case, what I've done is I plugged in a Wi-Fi device. This happens to be a Ruckus access point. And then from that Wi-Fi, you have a wireless connection over to your NDI. So in this case, I've got a connection that goes over to a NewTek Spark, which is one of the new NDI Wi-Fi devices. A Spark can actually plug in directly with an Ethernet cable, but it can also do wireless. So in this case, I've got an example of wireless. And then you would plug in your camera. In this case, this is an SDI Spark. So I've got an SDI camera that is directly plugged in. But with Wi-Fi, you can, for example, run a variety of other applications. So I might have an Android device, I might have an iOS device, maybe even a laptop running NDI. In fact, for this example, what we're running, the slides that you're seeing right now on the screen is connected to my Mac, which is running NDI. So I'm going NDI over to my vMix machine using NDI in this exact same scenario that you see right now, in that I'm connected wirelessly, and I'm bringing in an NDI feed into my vMix box. Now, when we think of wireless, the reason I call it wireless is because a lot of people just say, oh, wireless, oh, that means Wi-Fi. Well, actually it doesn't. There is lots of other wireless systems out there. In this case, what I've got here is I've got it's a point-to-point link. This is a Cambium wireless system, and it is a high-capacity point-to-point link. It's wireless, and it uses a completely different protocol than Wi-Fi. And off of that endpoint, off of that link, I could have NDI cameras, I could have some bird dog devices, I could have laptops, I could have a variety of other things plugged directly into my wireless link at the other end. So we're going to talk about Wi-Fi, we're going to talk about other forms of wireless as well. So that's kind of where we're going. So first of all, from wireless, what really makes this up? So RF, often you hear wireless, and it's basically radio frequency. So what is that? Well, radio frequency is really a very small part of what is referred to as electromagnetic radiation. So it's EMR. And we are exposed to EMR every day. There's natural version and there is man-made version. So electromagnetic energy is all around us. In fact, if you look at the slide here, you'll notice that sunlight is electromagnetic energy. That is actually our strongest source of EMR every single day. And it uses exactly the same principles, the exact same thing as what we're doing with wireless. If you look further down in the section under radio waves, in the blue, down about 3/4 or about a quarter way in, you'll notice that there is microwave systems, and that's really what we are in. We're going to be transmitting in what is called the microwave spectrum. Some of the other things that you might be interested in is that AM radio, FM radio, all of that operates in EMR. And then at the high end, after light, you'll also have, for example, you go for an X-ray at the doctor. Well, X-rays are part of electromagnetic energy. It uses exactly the same thing. We're just using it in a slightly different way with different frequencies. So that's what it's all about. So types of RF. So there is basically, and I say this carefully because all RF radio frequency is regulated worldwide. In some way or another, it's regulated. So in US, for example, it's FCC. In Canada, it's Industry Canada. In Europe, it's ETSI. In other countries, Brazil, Japan, they all have their own regulatory region that sets the standards for RF. And that sets the standards for the amount of power, what channels you can use, et cetera, et cetera. So I'm going to be talking about it in a fairly generic way, but obviously I'm from Canada, so I know the Canadian system the best. I know the American system, the FCC regulations fairly well, and Industry Canada and FCC are close, not exactly the same, but they're close. And so some of the things I will say are more North American centric, but I'll try to make sure that they are kind of worldwide specific. So first of all, they break down into really what is called licensed microwave. Licensed microwave is really reserved for the licensee in a particular area. So if you are, driving around and you notice that there are towers and you see big dishes, or if you look on top of buildings, you'll see big dishes, etc., of systems. All of those are very specific, and so a company has gone to one of these regulatory body, FCC or Industry Canada or ETSI, and has applied for a license, and they've been granted a particular set of frequencies in that particular area that only they can use. So there's no competing, there's no interference sources, or there isn't supposed to be anyway, and it makes it very clean for them to use. That is not cheap. They pay for a yearly fee as well as the equipment. It is generally way more expensive. So some of you might come across this if you have a business that requires a licensed microwave from one building to another building across the city or something along that lines. But it's really in the tens of thousands of dollars that you're looking at for licensed microwaves. So that's really not an area for what most of you are going to be working in. But it's certainly something that you can do. You can send video over licensed microwave extremely easily. And then you also have something called unlicensed microwave, and that's really where we're going to be operating in for the most part. Unlicensed microwave largely in most parts of the world is 2.4 gigahertz and 5 gigahertz. In some areas, 900 megahertz is also available. And the thing is with unlicensed microwave is that anybody can use it. You can use any frequency as long as you're within the regulations. However, that means that there is competing transmission. You have no control of what somebody uses, so there could be somebody that is very close that is causing you interference. Interference issues vary greatly and they're not consistent. All right, we're going to try to keep our sessions between about 30 and 45 minutes. So that's where we're going to break for this particular session. Some of the things that we covered today was we looked at NDI, what it is, where it's come from, and kind of how it fits into the whole spectrum of other protocols. Why is it important for us for our video production? Then we also looked at some issues with PoE, what the difference is between 802.3 AF and AT. We looked at switches, power, and tried to give you a better idea of what kind of equipment you needed to look for and some of the things that you needed to watch when purchasing equipment. Then we also started to take a look at our RF and how wireless works in general. And we also looked at the difference between licensed and unlicensed microwave. So those are the topics for today. When we return for the next session, we're going to start really looking into the wireless protocols, and particularly for the next session, we're going to be looking at Wi-Fi and some of the ins and outs of Wi-Fi, how it's used, why it's used, what are the pros and cons, and what are some of the things that you really have to be careful with in terms of setting up. So that's what we're going to be covering in the next session. So thank you again very much for watching, and we're going to I look forward to seeing you for next time. Take care.